girl. You're a good girl. You can stay there. All right. Makes things ever so much brighter. Hi, Vanessa. Oh, she can't hear me yet. Hi, Vanessa. Dylan's in. Hi, Vanessa. You being shy on me, Vanessa?
Hello again.
Hi, Dylan. How's it going?
Pretty good. How about you?
Just happy to be here. I'm actually happy to get this thing done with.
Seems like a pretty easy one.
It's literally, if you were doing it in person, it is a piece of cake. All you got to do is take the powder, put it into a crucible, heat it up, let it cool, weigh it, heat it up again, weigh it again. If it matches, you're good. If not, you got to heat it up a third time. It's very, very easy. So I don't even know how many people are going to be here tonight. I got 3 of you. So Vanessa's being shy though. She won't come out and talk with me.
I'm sorry, I just realized my computer sound wasn't on.
Uh-huh. That's a likely excuse. Vanessa, you don't have me in lecture, do you?
No, I don't.
Okay.
I'm with Musgrave.
Good for you. Good. Absolutely fantastic. Guys, just make sure you realize that you have because this is an online class, you have 1 lab due every Sunday. It's like the previous lab report and post lab, and the next lab pre-lab is due on Sunday night. Are we good with that? We kind of understand that?
Yes.
Okay, it's 7:15. Did I tell you guys 7:30 to start this?
7:15.
No, I know I did tonight, but did I normally just say 7:30?
No.
Okay. Then I tell you what, we're going to get started because I don't know how many or if anybody is going to join us. So it's literally, this is a very simple lab. It's easy to understand. And, oh, why did that stop? Okay. You're seeing the screen, I take it.
Yeah.
Okay, have you ever seen the little packets? I actually just got a leather couch, but have you ever seen like the little packets that you get in shoes where you have this little packet is filled with powder? Do you know why they put that in there?
It absorbs the water, right?
Yes. Preferentially, it will absorb water, thereby keeping your leather fairly dry. All right. The reason it does it is you have some salts that basically are able to incorporate water into their crystalline structures. Now, it's not really bonded to the salt, but it's kind of incorporated into the structure. So when you're dealing with these things, if you want something like number of moles, you have to include that weight into getting the molecular weight, because if you don't, you're going to be shortchanging yourself. So the water is not really bonded to the salt. And therefore, when you take this salt, and by the way, guys, when I talk salt, I'm just talking about an ionic compound. Okay, when you take a salt and you heat it up, what happens is that takes the water and it evaporates it out of the crystal. Now, the crystal itself still wants that water, but at a high temperature, it's not going to be as able to hold on to it. So you heat these crystals up, all the water goes away. So you now have this powder that acts as something called a desiccant. A desiccant is something that will absorb water from other areas, like the atmosphere. So if you put these little packets in with your shoes, then the water that's in the atmosphere around the leather gets sucked into this salt crystal, and it's not around your leather. Now, before we do this lab, we have to understand a term called percentage. Percent per 100. Basically, what you are doing when you're determining a mass percent is you're determining a proportion of the substance you're interested in compared to the amount of the entire substance. If we set the portion at 100, all we're determining is how much of that 100 is the portion, the percent. If we set the whole portion at 1 million, then we would be determining how much of the 1 million is the portion, the parts per million. So, and there's also something known as parts per trillion. So all we are talking about is a portion of the thing you're interested in versus the entire substance. So if we're talking about a mass percent, we're going to take the part we're interested in, we're going to divide it by the whole, multiply that by 100, that will give us our mass percent. If I was talking about parts per million, I would take the part, divide it by the whole, and I would multiply it by 1 million. Now, if we have the mass of the part and we have the mass of the whole, all we got to do is divide the two and multiply by 100, and we get the mass percent. If we have the molecular formula, we can take the atomic masses of the things we're interested in, add those all up, and divide that by the atomic masses of the entire molecule, and that will also get us a mass percent. So I have two ways of getting a mass percent. If I do the experiment itself, and I'm able to determine how much of the part weight I have and how much of the whole weight I have, I can get a mass percent. Or if I have the entire molecular formula, I can take the part that I'm interested in, take that atomic weight, and divide it by the molecular weight of the whole thing. That will also get me a mass percent. Okay, by experimental weighing. First thing we're going to do is we're going to weigh out a crucible. Then we're going to add some hydrate to it. A hydrate is the salt with the water still in it. I add the hydrate and crucible. I subtract the weight of the crucible out, and I have the mass of the hydrate. Now, what I am going to do is I am going to heat the crucible and the hydrate. When I do this, I evaporate the water away from the salt, leaving what is known as the anhydrous salt, or salt without water. So what I'm going to do is I'm going to heat it up. I'm going to let it cool. And I'm going to weigh it. Then I'm going to take that same crucible with that same amount of my anhydrous, and I'm going to heat it up. And I'm going to weigh it again. Now, why did I weigh it? Why did I do that? Anybody have any idea why I'm doing that?
To make sure that all the water is evaporated.
Exactly. If I can get a consistent weight, that means that I have driven off all the water. If I get a weight that's within 0.1 of my previous weight, then I'm fairly sure that I've gotten all the water away. Now, we live in Florida. Can anybody think of an automatic error that we are going to incorporate in this experiment because we live in Florida?
Humidity.
Your humidity. If we were in someplace dry like Arizona, then we wouldn't have to worry about it as much because of the fact that there's not much water in the atmosphere. Because Florida has this tremendous amount of humidity there, there's a lot of water there. So that isn't, while you are waiting, while this crucible is cooling down, it's also exposed to the humidity in the air. So it's also sucking some of that humidity back. So once I have gotten a real good replicable weight, I take that weight, I subtract the weight of the crucible out, and I have the weight of the anhydrous.
So do we use the second reading or the first?
I would always use the last one.
Okay.
Okay, you would never use the first one because you've obviously lost a 1/10 more gram of water. Okay, does that make sense to you?
Yeah.
Even if this weight went up a little bit, say if my third weight was 38.821, I would go ahead and use the third weight anyway. Okay?
Okay.
It's not going to matter too much at that point. So I have the mass of my anhydrous. Now, remember what we're going after. We're going after mass percent. In this particular instance, we're going after the mass percent of water in the sample. So our part is the water. Can any of you suggest a way we are going to be able to get the weight of water from the information I've given you thus far?
Would you subtract it from the initial weight?
All right,
And
think about this, guys. I have the weight of the salt without water. Don't I also have the weight of the salt with water? If I subtract the amount of salt with water and the amount of salt without water, I will get the weight of the water. There's also another way. The crucible weight is not going to change. So if I measure the mass of my anhydrous with the crucible and subtract it from my anhydrous, or from my hydrate with the crucible, I'm also going to get the same amount of water. So both of them, if I subtract the hydrate and the anhydrous, I get 0.693 grams. If I subtract the crucible and hydrate and the crucible and the anhydrous, I still get that same amount of water. Now I've got the part. Can anybody tell me what my whole value is?
Is it the mass of the water and the anhydrous together?
Okay. What would that be?
Oh,
You could add the two. Yes, you're exactly right. You could re-add these two together and you are going to get the weight of the hydrate. So literally speaking, my mass percent, my percentage water is going to be my mass of water divided by my mass of hydrate, or the 0.639s divided by 1.325, multiply that by 100%. That gives me my percentage of water in my sample. Any questions to this point? Fairly straightforward, guys?
yeah.
All right. Now we're going to have to do the second calculation. I have to figure out my mass percent using my atomic masses. Okay, I want to determine whether my compound could be barium sulfate dot 5 H2Os. So what I'm going to do is I'm going to use this molecular formula. And I'm going to determine how much of this molecular formula, the percentage of water that's within this particular compound. Then I am going to compare it to my experimental value. So what I'm going to do first off is I'm going to figure out the contribution of water using the atomic masses of hydrogen and oxygen. And I'm going to multiply that by 5. Then I'm going to determine the entire molecular mass using the entire molecular formula to make that determination. I've got 5 H2Os. This means I have 10 H atoms. 10 times 1.008 equals 10.08. To this, I'm going to add the 5 oxygen atoms, or 5 times 16, which gives me 80. I add those two together. Water's contribution to the entire weight of this molecule is 90.08 grams. Okay? Barium sulfate. Barium weighs 137.33. There's one of them. So that gives me 137.33. The weight of my sulfur, there's only one sulfur atom. 1 times 32.06, this gives me 32.06. I have 4 oxygens times 16. 4 times 16, 64. I add all of these guys up, that gets me 233. But remember, for the entire weight, I have to also include the weight of the water. So my 5 waters weighed 90.08 grams. So my entire molecular weight was 323.47. To get the mass percent of that, all I have to do is take my mass of my 5 waters, the 90.08, divide it by the mass of the entire molecule, multiply it by 100, and I have 27.85%. Now what I'm going to do is I am going to compare it to my percent water for my experimental value. They match fairly good, so I can be fairly confident that my formula for my compound is barium sulfate, 0.5 H2Os. Do you have any questions, guys?
I'm good.
Nope.
This should be a fairly easy one for you to do. Hearing no dissension, I move that the meeting be adjourned. Do I have a second?
Aye.
Motion carried. Seriously, anybody need any help either with lecture or lab at this point?
Can I ask, can you go over how to submit a photo to Quizlet, or the
I
submissions
can show
again?
you the instructions.
Okay.
Would that be
Because
okay?
I used the instructions and it didn't work for some reason. So I don't know if it was just my picture.
I don't know what to tell you, Vanessa, then, because I am not technically gifted.
Okay.
Okay. Vanessa, I'm going to set up a chat room in here. Does anybody that's left in here, do you know how to upload a picture do you know how to upload a picture into my courses? Blake, Dylan, Jackson?
Using
Would you be
Enter.
willing? Would you be willing if Vanessa gets onto a discussion forum for the lab class? Would you be willing to answer her, please?
Sure
Yeah.
thing.
Good enough, Vanessa? Does that help you?
Yes, thank you.
I will, as soon as I get done with this, I'll go on to the website to make sure there is a student forum for you guys to make discussions with one another, okay?
Okay, thank you.
No problem. Anything else anybody needs to discuss? Okay, ladies and gentlemen, you have the report for this and the post lab for hydrates, and you have the empirical formula lab, pre-lab for next Sunday.
all right.
See you later. Take care,
Thank you.
guys.
See ya.
Thank you. See you.